Hi, my name is Edwin Galvan, and today I'm going to be presenting the labs I have done through my chemistry first quarter. The first one is dancing ghosts, and the materials are appearing in the screen right now. Dancing ghost lab was the chemistry behind it is the balloons tend to have positive charges in them. When you rub them against the hair, they get charged with negative energy. This tends to pull small and light positive energy things against them since the balloon has a negative energy on it and the paper has a positive energy. They get to attract to each other. The term for this is opposite poles attract to each other. The second lab I did was fuzzy bombs. The materials are appearing on the screen as you can see. The bad bombs. The objective of this lab was to see the chemical reaction some products have, like sodium bicarbonate has when it gets in contact with liquid water or acetic acid. In this case, it didn't come out as planned. When I put my bath bomb in the water, I didn't have any reaction. When I tried it with acetic acid, I realized that my phone wasn't recording, so I don't have any clip of that. But the bath bomb had a big reaction to the acetic acid. When the sodium bicarbonate touches the acetic acid, they both release carbon dioxide. As you can see here on the screen, I am mixing water with colorant so I could put it on the baking soda or the sodium bicarbonate. I also added a little bit of essential oil so it could smell good. Basically, pretty much, I just added a few drops of essential oils into the water. As you can see, I'm doing in the screen right now. I was actually looking for my favorite, that was lavender, or yeah, I think it was lavender. Anyways, what I did right there was added like a few drops, maybe a little too much. I think I did add it a little bit too much, but I love the smell of lavender. So I just like mixed it together and put everything together and started adding slowly to the mixture. Not to the mixture, to the sodium bicarbonate right there. As you can see, I'm about to start pouring a little bit by little bit of water into the sodium bicarbonate so it doesn't have a big reaction. And right there, it kind of just started forming like a paste. Once I had it like in the consistency I had, like right there, I just added a few, added a few drops of water at a time. That way it didn't become as liquidy. Right there you can see that it's kind of like has a form where you like more manageable. And I actually like started cleaning on the desk a little bit. As you can see right there, the mixture was already perfect. I just decided to add a little bit because it was a little too dry and I was afraid that it wouldn't hold its shape, so I just added a little bit more water and kept mixing. Look, you can see that when I pinch it, it holds its shape, so I knew it was ready. After that, I got a piece of plastic wrapper and started to form a bowl. Right there, I used like my measuring cup to help me out to like kind of have the shape of the ball a little bit. So I just put the whole mixture inside of it and kind of put pressure on it so it can like came out as one thing. Look, as you can see right there. And this is because the molecules that are on the not the molecules, the shape of the ball, it's not too dry and not too liquidy, that it can actually be managed. Right there, I kind of just tried to make it a ball, and now leave it just like whatever it was, you know. So right there, I just kind of put a little pressure on it, and once it was ready, I took it to the fridge, and it, like 20 minutes it was in the fridge, then it came out and it was a ball. So right there, I'm just like uncovering it. Then I grabbed some water it was at around 500 milliliters, and I just throw it inside. As you can see right there wasn't any reaction, and I was confused why there wasn't. But something that I find out was that baking soda or sodium bicarbonate doesn't have a reaction with H2O. But when I did the acetic acid, it worked and it had a perfect reaction, and a lot of bubbles came out of the reaction, so it was perfect. Our next episode, our next lab is gonna be inflating a balloon with CO2. The main purpose of this is to inflate a balloon with CO2 using acetic acid and sodium bicarbonate. And what would happen if I changed the element amounts to see what would happen? The steps were to fill the balloon with sodium bicarbonate and the bottle with some acetic acid. Something I noticed was that the balloon was heavier than the regular inflated balloon, which is funny because they're both CO2, but the one was made from my body and the other one was made from two elements, which was the sodium bicarbonate and the acetic acid. As you can see right here, I made a funnel with a piece of paper so I could add the sodium bicarbonate inside the balloon. And I kind of struggled right there, but I've managed to make it work, if I do say so myself. Right there you see that I kind of make it work. So we were good there. I started adding the sodium bicarbonate right there, and I didn't realize that my phone was recording in slow-mo. So it just part of my experiment is in slow-mo. I apologize for that. But as you can see right there, I already added the sodium bicarbonate inside the balloon, and now what I'm doing is adding the acetic acid into the bottle. Right there I just added the acetic acid into the bottle. So once I have it ready, I put the tip of the balloon on top of the bottle, and I hold it with my hands, and I kind of just throw the sodium bicarbonate into the acetic acid and started to releasing CO2. So right there, that's what I did. And as you can see right there, there's the balloon. It was heavy than it usually was. I felt that it was heavier than a regular balloon. Then I kind of inflated another balloon with CO2 as well, but this CO2 wasn't made from the two elements, the sodium bicarbonate and the acetic acid. This was actually made by myself, but the one I released when I breathe. So right there, the balloon I noticed that it was heavier than just a regular balloon, and I kind of went and, like I said before, got another balloon, inflated it, and kind of compare how heavier it was. And I noticed that it was heavier, but I have no idea why that was, or what the math behind it is, the chemistry behind it is. I'm sorry. Look, as you can see, the one orange is the one I used to fill with acetic acid. Our next experiment is testing the level of pH in different liquids. For this experiment, I used something really simple and something that we all have at home. I used red cabbage, the water of boiled red cabbage. That's right there, the one I'm showing in the big jar. The purpose of this lab is just test the level of pH on different liquids. Like for example, right here I am using water, tap water, acetic acid or vinegar. I have apple cider vinegar, and then on the far left I have Gatorade. So as I said, the main purpose of this is to test the level of pH each liquid has. As you can see right there, I'm pouring the red cabbage liquid into the water, which turns into a bluish kind of thingy. This indicates that we have a base. Now, what does this mean? That means that the level of pH is more than 7, which everything above 7 is considered a base or alkaline. Right there we have the acetic acid or just vinegar, white vinegar. As you can see, that's more of a reddish slash pinkish color. This means that this is an acid, and something below 6.9 is considered an acid. Right there you can see that the apple cider vinegar had almost the same color as the regular vinegar, and right there we have the Gatorade, which had almost the same reaction. Had almost the same color as the apple cider vinegar. Now, red cabbage is a good pH indicator is because it contains something called anthocyanin, which turns red when it gets in touch with an acid, and it turns blue when it gets in touch with a base or something that we consider alkaline. So you can see that right there, the alkaline thing is the water. Our last experiment of the day is oobleck. For this, the main purpose of oobleck was to see 2 out of the 3 states of matter in just one place. When I applied pressure to the oobleck, it acted as a solid, but when I just held it in my hands without applying any pressure, it became a liquid. The reason for this was because I applied pressure to the molecules, so the molecules were compact and they couldn't move as much as I would used to when I'm not applying pressure. As you can see right there, I am hitting with my hand and my hand just doesn't go through, but when I relax it, it goes straight through like if it was water. The reason why it acts as a solid is because when I am not applying pressure, all the molecules can move freely and have more space to move. Right there you can see I was trying to mix it, but it was hard because it was just too much. This is my whole semester, all the labs I did this semester for chemistry, and I really enjoy them. I really learned a lot from them. I just gotta say that I had so much fun for them, and some of them I even made them when I was talking to my friends. We all did them together on a phone call. It almost looked like I was in school with them doing it together. That was it. My name was Edwin. This is my whole 10th grade, sorry. My whole 10th grade project, and I really enjoyed it, and thank you very much. Thanks for watching.